Yes, class. Am I audible to all of you? Faiza, Tarif, Yusuf, Shahid.
Assalamu alaikum, ma'am.
Walaikum assalam. Yes, Yusuf, how are you?
I'm fine, ma'am. How are you?
I'm good. So, how's your preparation going, Yusuf?
We're just doing revision.
Okay, okay. See, Yusuf, I'm starting. Yusuf and others also. Others I've already informed. Yusuf, since you didn't join, so I'm informing you. We'll be starting with the revision of modern physics first. So from modern physics we'll start, then we'll see how we have to go about, depending upon. And one more announcement for all of you. See, I hope you have already been informed about the test series. Revision test series will be going on. So whatever we'll complete today, that lesson will be coming in your revision test series. Now the advantage of this revision test this time is that wasn't there last year, is that you can give test according to your convenience. For example, if I say we have completed dual nature of radiation and matter. All right. So suppose Faiza has completed it. So Faiza is comfortable in giving the test on Friday. Let's say Tarif wants one more day, so he can give the test on Saturday. Shahid wants to give the test on the same day with Faiza, so he can give. Suppose Yusuf has joined late, so he wants more time span for the preparation, so he can give the test on Sunday. Like this, according to your convenience, you can fit the time, one chapter each. One chapter only will come in your exam. This will benefit you so that you can at least you will not say that I have not completed the portion, because many times this was faced. We faced the same issue. Yes, whenever we had the tests, you people were not able to complete the syllabus. So this the advantage will be that you complete the syllabus. We'll be having the class. We'll be having the revision classes also. I'm starting with dual nature of matter and radiation. So we will see whatever portion we have completed, you revise it. I have already told you these are revision classes. So I'll not be teaching you everything in detail. It's a revision class, so it has to be interactive. You have to unmute yourself and answer. It's better if you unmute and answer rather than texting. You can text also in the chat column. Doubts also you can let me know, whatever doubts you are having. But the advantage of these test series is that these test series will be conducted as per your wish. Every student will be having a different test series customized depending upon whatever you want to have. So like this, you can have the test series in whichever manner you want to have. In whichever day you are comfortable, you just have to inform this day I'll be giving the test. So that lesson you have to prepare yourself. So this is the first revision class. Today we are having it because on Saturday, I think your another class has been scheduled. So that you will see. But otherwise, we'll be having the classes on Saturday and Sundays only on the regular timing. This week we'll be having it like this. It can happen that the next weekend there will be a little shuffling, but we'll see that later. Let us start with the revision first. Dual nature of matter and radiation and matter. Firstly, one thing that you all should be knowing, and one thing, be interactive in the class. Keep on answering in the class, then only you'll remember everything here itself. First thing, if we talk about dual nature of matter, we had this concept of 1 electron volt. So how do we convert 1 electron volt? How much joules it is? Yes, class. How much joules it is?
Um, 1.6 into 10 to the power of minus 19 joule.
Yes, correct, Yusuf. Very good. The electronic charge which you hold, the electronic charge which is held by an electron, that is only the value of this E. See, the value of this E is 1.6 into 10 to the power minus 19. So when I'm talking about 1 electron volt, this will be this much amount of joules. So this is a conversion that is very important, which you should remember. Why? Because energy gained by the electron, we have done this in the electrostatics also, that it's the work done by the electric field. These things can be utilized. Energy gained by the electron, this is basically work done by electric field. We'll be doing numericals also, but let us first cover the theory portion. We'll be doing numericals. Numericals also you all will also be solving, and I'll also be discussing the same. Now, when we're talking about the free electrons, in metals, electrons in the outer shells, you have the nucleus. Now, when we're talking about electrons and atoms, atoms also we have completed. So in metals, electrons in the outer shells of atoms, these are loosely bound. All these electrons, these are loosely bound. So they move about freely throughout the lattice of the positive ions. So these electrons are called the free electrons, right? Now, these electrons have the tendency, if a certain wavelength, if a certain frequency, if a certain energy, if a certain voltage, all these are provided, certain frequency, certain voltage, certain potential, certain energy. All, if any of the, every electron, suppose this is one electron I'm talking about, this electron will be having its own wavelength, this will be having its own frequency, it will be having its own energy, and it will be having its own potential. This value is fixed for every electron, a minimum value. This electron which I have drawn here, this electron requires a minimum value of the wavelength to escape, because it's already free. So it means it has the ability to escape the outermost shell of the electron, right? So it means there is a minimum wavelength which is prescribed for this electron. Similarly, a frequency has been prescribed for this electron, and energy is there for this electron, and these are all the minimum values which have to be present, then the electron can be freed. This is the minimum value. Minimum value means the value of the energy which you are providing. It can be this much or more than this, but not less than this. That's why minimum value. So if suppose I am providing some energy, I am providing this energy. So this energy which I am providing, this energy, so that this electron becomes free and escapes this metal surface, it has to have this minimum wavelength, minimum frequency, minimum energy, minimum potential. So minimum frequency, minimum wavelength, we called it as the threshold wavelength. This is called as the threshold frequency. This minimum energy, this is called as the work function. And minimum potential is called the stopping. This is called as the stopping potential, right? So what is work function? Because you have to write the definition in your competitive exams, which will be appearing after class 12's board exam. There you don't have to remember these definitions. But for your CBSE, for your board exams, you have to write down every definition. So you should remember the definition of all these three. So minimum amount of energy required by an electron to just escape the metal surface will be work function. And this way you can just change the definition. Now, see, there was experimental study of photoelectric effect done. So this is one concept. Now, before we start with it, see, energy can be transmitted, which I had mentioned in the class also. So this is the introduction part. Okay. Now see, these are the 4 types. I'll give you time to all of you, though. I think only Yusuf does not have the notes. Otherwise, you all have these notes also with you. Yusuf, I'll share the notes with you. Handwritten notes are there. I'll forward it to you on WhatsApp. So there everything is written in detail. So that's why you don't need to write everything. Okay, Yusuf?
Sure, ma'am.
Okay. Now see, different methods are available through which these emissions can occur. All right. How these electrons are released, we are focusing now on that. We have understood the fact that yes, minimum this amount of energy, wavelength, frequency, these are required, and the minimum criteria is called the minimum criteria is called the threshold. Now for the electron to be ejected out of the metallic surface, there are various amounts of energies processes that are done. First one is the thermionic emission. So when a metal is heated, suppose this is a metal, this is heated. So when a metal is heated, it gets the sufficient thermal energy. All right. And they can overcome the surface barrier. So this method of removal of the electrons is called the thermionic emission. And the emitted electrons, now the electrons which will be emitted through this process, we call them as the thermions or thermoelectrons. Thermions or thermoelectrons. Secondly, field emission, which we called as the cold cathode emission also. This is one more name also, cold cathode emission. So when a metal surface is subjected to very high electric field, if the electric field is very high, you can say from 10 to the power 3 to 10 to the power 8 volt per meter, around this much. If the electric field is very high, so what happens? Electrons are emitted. So this is what we call as the field emission. When the term field is used, this means this is silently talking about the electric field. So electric field energy or cold cathode emission. So, but one more thing, this method of electron emission is dangerous and it's less efficient also. So this is hardly used. It's dangerous also because of the high amount of electric field. It becomes dangerous. So this is less likely to be used. Then you have the secondary emission. Secondary emission is the easiest one. Two electrons are present like this. One is a very fast moving electron. So when a fast moving electron strikes the metal surface, so what happens? The free electrons, they become available for conduction. So as a result, what happens? The energy of the free electron becomes more than the work function. And what have I told you? When the work function is crossed, that minimum value of work function is crossed, electrons will be emitted. So also we call these electrons as the secondary electrons. We call these electrons as the secondary electrons. All right. So this is also used. This method is also common, but the most common method and the most important method which we have is the photoelectric emission. So it is the process in which electrons are emitted from the metallic surface. Same thing. Difference is that electromagnetic radiations of sufficient frequency, or you can say the incident frequency has to be high, basically threshold frequency. That's why initially only I have told you the terms threshold frequency and all. So when electrons from this metallic surfaces, they are drawn out because of the striking of these electromagnetic radiations of high frequency. We call this entire process as the photoelectric emission. Photo because the electromagnetic radiations are used. That is rays are used. All these EM waves you all have heard of, you have all studied in detail. You already know the spectrum. So all these EM waves are hit upon. And all these EM waves which we have studied, entire spectrum, from gamma, when you're starting with the gamma rays, to the radio waves, all these waves are included and contribute to photoelectric emission. That is using your light rays. This is the process by you can use the light rays. Now, this is all about the portions that are included before, that is before the photoelectric. When we talk about the photoelectric, One thing that you should just remember and keep it in your mind, though that experiment has been deleted from the board exams, that this experiment, when we're talking about the discovery of the photoelectric effect, one thing that you should remember here is, just for your knowledge, that shouldn't come in your exam. This was done by Hallwash and Lennart. There was an experiment. Firstly, there was Hertz observation done, after whom we put the frequencies SI unit Hertz. That was done. So he also used some high voltage sparks and some detector loops like this. He used the electromagnetic wave which he used was the ultraviolet. Yeah, he used the ultraviolet Hertz. Then his time was over. He did some experiment, but everything wasn't concluded. Then came this experiment by Hallwash, because this name is mentioned in your textbook. So that's why you should have the idea about this. And Lennart's Hallwash and Lennart's observations, these were done. And they were the one who investigated the phenomena of photoelectric effect in detail. Again, they also use the same electromagnetic wave, that is the UV light, ultraviolet light. They also use the same light. So an experiment was done, UV light was struck upon, zinc plate was there, then electroscope gold leaf experiment. It was similar to gold leaf experiment, and something was observed, which you shouldn't go into the details. What were the conclusions? That you have to remember. All right. You have to remember the conclusions about these experiments. So when this setup was then constructed, this setup was done properly. Who gave this setup? This setup was done by Lennard, was still there with the experiment. Hallwash left the experiment. He gave all the observation that basically they told about the threshold frequency and the photoelectrons were transmitted and all. That they told. Hallwash left, but Lennard was still on the experiment. So what did Lennard do? Along with we have heard of Millikan. Remember Millikan experiment or drop experiment also. He did to calculate the charge on an electron. So same Millikan, R.A. Millikan. Millikan and Lennard, both of them, just a second. Yes, Lennard and Millikan, both of them, they did this experiment. So some conclusions were further drawn. Those conclusions will come in your exam. They are very important. The experimental study of photoelectric effect. The heading can be asked as the experimental study. Experimental study of photoelectric effect. So when experimental study comes, this experimental setup will be there. That is, you'll be having, see here, this is a photosensitive plate which is connected. Photosensitive plate is connected. There's an outlet. This outlet is known as a quartz window. This is known as a quartz window. All right. So basically sun rays were hit upon it. Electrons, this tube, this is the evacuated glass tube. This is the evacuated glass tube. This is the photosensitive plate. This is the collector plate. This is the collector plate. All right, so this was the arrangement that was done here. Ammeter is connected, voltmeter is connected. Then rheostat is connected to modify the current, to regulate it. Key is there, battery is there. Microamp, it measures the current in microamperes, that is 10 to the power minus 6 amperes. This is how the experiment was done. So light rays were hit, electrons moved to the collector, that was detected and calculated by the ammeter. Voltage was calculated, and using resistance, the amount of flow of electron was regulated. Because when you modify the resistance, the amount of current that is flowing can be regulated. All right. So here the photoelectric current was only flowing because the rays that were taken were from the sun. That is the electromagnetic radiation. Those were taken through this quartz window. So that's a whatever current this will be giving. This will give the photoelectric current only because these electrons are the photoelectrons. So this was the experiment done by these two. All right. Now, what you have to remember the conclusions that they are giving. Before we start with the conclusions, because the conclusions are very important and easy also, you just have to remember the graph. What all things we have discussed, that all these minimum things, these definitions can come in your exam. Minimum wavelength, that is the threshold wavelength. So these definitions are also asked regarding the threshold wavelength and threshold frequency. Minimum frequency is the threshold frequency, minimum potential is the stopping potential, and the minimum energy is the work function. Then all these definitions have the same definition. You just have to replace minimum dash is called the threshold dash, like this. So all the definitions are very easy to remember. Then this value you have to remember because in your numericals this will be used. Then you have to remember by the method in the notes, handwritten notes, everything is present. You should revise it today also, and then you will match it. And with Yusuf, I'll share it right now only. So these are the types of the emissions which are going on through different methods through which electrons can be generated. Out of which you have this method, fourth one, photoelectric emission, to write in detail. So initially, Hertz did an experiment using ultraviolet radiation, which is falling on the metal surface, which caused some negatively charged particles to move, and voltage was also being regulated, but nothing more than that could be concluded. Then Hallwash and Lenard's gave some experiment using UV light that was hitting on a zinc plate, and then this electroscope was present that detected the current, and some experiment was done by Hallwash and Leonard. So they initially gave the terminology that is threshold frequency. They told about the threshold frequency and that photoelectrons were emitted enough. Then photoelectric effect definition is very important. And after this, Leonard and Millikan, they gave the experimental study of the photoelectric effect. This was the experiment that was done. Now, what was the experiment? This was the experiment, but apart from this, different hit and trials were conducted. That is, intensity was increased to check the amount of current, kinetic energy was calculated, stopping potential was calculated. Like this, different criteria were kept, and different conclusions were drawn off. So first is the graph plotting separately can also come, and conclusions of the experimental study of photoelectric effect. This way also question can come in the exam. So the first question that is possible and the first observation that was done was the relation between the photoelectric current and the intensity. Photoelectric current and the intensity. So if the radiations of the certain frequency were fixed, now photoelectric current was found to increase linearly with the intensity of the radiation. Reason was that the number of photoelectrons, this was increasing. Number of photoelectrons increases proportionally, that is directly proportional to the intensity of the radiation. This is the intensity of radiation, this is the amount of photoelectric current. So you get a direct linear relationship. Then you have the effect of potential. Effect of potential. See, photoelectric current increases with the accelerating increase in potential. Understood? When we are seeing the effect of potential. So what was observed, that photoelectric current, this is the graph of photoelectric current, because we'll be having negative values. So that's why this has been started from here. So photoelectric current increases with accelerating potential. Best way to describe this is accelerating accelerating potential. So accelerating potential because this is increasing till a stage is reached when the photoelectric current becomes maximum. Suppose I'm talking about this first one, I1. Frequency is kept fixed. So current is found to, photoelectric current increases with the increasing accelerating potential till a stage. A stage is reached when the photoelectric current becomes maximum and does not increase further with the accelerating potential. We call this maximum current as a saturation current, and this is the graph which is plotted. So when the intensity is increased, this is how it will vary. You keep on increasing, just the magnitude will be increasing, but the pattern will remain the same. Now, the value of this retarding potential. The potential which is decreasing, this is accelerating. The potential which is deaccelerating, which is decreasing, where the photoelectric current becomes zero. This is called the stopping potential. What is stopping potential? Here the photoelectric current becomes zero. When it was accelerating, photoelectric current was having a certain value. When it is decreasing, as soon as it becomes zero, this is called the retarding potential, which we have a specific name for it, stopping potential or cutoff potential. Stopping potential or cutoff potential. This formula we'll be studying now. Effect of frequency. Now see, basically to study the effect of frequency, one thing that was kept constant, intensity of the incident radiation at each frequency, it was adjusted so that this was kept constant. Basically intensity was constant this time. Frequency was constant when intensity graph was plotted. Now intensity graph is being now frequency graph is being plotted, so intensity is kept constant. All right, so potential is gradually reduced to zero. Here these are the values where the potential's value is zero. All right, so this is how the graph was obtained in case of each frequency. All right, this was adjusted in a manner that every time we get the same maximum current. This also gives you the same amount of maximum current. Which is the maximum current? I told you the name of the maximum current is the saturation current, which does not increase further. All right, this does not increase further. All right, so what can you say? What are the implications of this graph? This implies that the greater frequency, see, greater frequency of the incident radiation, greater is the kinetic energy maximum. Frequency will be more, so kinetic energy will be more. All right, so maximum amount of kinetic energy more, so there is the greater is the retarding potential required to stop electrons completely. Yes, right, Chavez. Stopping potential increases. Why it increases? Because this frequency is increasing, kinetic energy of photoelectrons is increasing. So very rightly answered by Chavez, the stopping potential, that is the retarding potential required to stop the electrons completely, this will be also more. That's why this is the pattern of the graph which we are getting. So frequency, then maximum saturation current. Why this is saturated? Why we are getting the same amount of current? This is done experimentally. This was regulated to get this maximum value. So this is how the effect of frequency was plotted. All right. This is how the frequency was plotted. Okay, so threshold frequencies definition also we have discussed. Now the kinetic energies graph. See, this you can see here only, it will be clear. Laws I'll discuss separately. Kinetic energy and frequency are directly proportional. That's why here also, when frequency increased, kinetic energy increased. Why? Because frequency is regulates the velocity. Frequency is directly proportional to velocity, and velocity is directly proportional to kinetic energy because of the equation half mv square. And why they are directly proportional? Because frequency into wavelength is equal to velocity. All right. So if frequency increases, velocity will increase. And half mv square is equal to kinetic energy. So if velocity increases, kinetic energy increases. So this is the relation. Frequency increases, how the maximum kinetic energy that will be increasing. So that's why frequency and kinetic energy have a direct relationship, that is both are directly proportional to each other. All right. But kinetic energy is independent of the intensity. You keep on increasing intensity because kinetic energy is not depending upon the number of electrons, right? It's not depending upon the number of electrons. So if it's not depending upon the number of electrons, it won't have any effect on the kinetic energy. Number of electrons will increase because of intensity. Number of electrons will increase, but that won't increase its velocity. Velocity won't be increasing, right? So these were the graph. All these graphs you have to remember. Effect of frequency graph, effect of potential, stopping potential, definition of stopping potential, and this photoelectric current versus intensity. Now all these are so distorted, right? All these are so diffused. When we are talking about the laws of photoelectric effect, this let me tell you separately. See, when we are talking about, if a question comes to you to write the laws of photoelectric effect, firstly, some things you should remember. All these experiments, all the experiments which we discussed, what did they tell? That the stopping potential, some conclusions you should remember. This page you have to write. This you can write it down later. First, understand it. Then I'll be asking you these, because these are some important things that have come in the previous years. So that's why I'm discussing it. Firstly, you should remember that the stopping potential, this is the stopping potential. This increases linearly with the frequency of the incident radiation. This is not the threshold frequency. This is the frequency of incident radiation, which you see. This has certain frequency, which we call as the threshold frequency. The light ray which we are striking, this is called incident radiation. It also must be having some frequency. This, when this knot is put, this means I'm talking about the energy of the electron threshold. But when I'm not putting this dot, this means I'm talking about the frequency of the incident radiation. This radiation which has been incident in order to make this electron available for conduction and photoelectric effect to occur. So one very important conclusion that you have to remember is that stopping potential increases with the increase in frequency. That is, stopping potential increases linearly with frequency of incident radiation. This you have to remember from the graph. This is the conclusion from the graph. The graph between what stopping potential was there, no? Graph between the photoelectric current and stopping potential, where different frequencies were there. So this is the conclusion from that. Then from that graph only, the definition of threshold frequency arised. That is there is a minimum cutoff frequency. Let me write it. There is a minimum cutoff frequency for which the stopping potential is zero, and photoelectric current also becomes zero. And this minimum value of frequency below which photoelectric effect stops, or above which, or which is required for photoelectric effect to occur, is called as the threshold frequency. So definition of threshold frequency is very important. All right. And then those two, we already did that maximum kinetic energy. That was also important, but these two conclusions from that graph, that was very important. All right. The rest of it, we have done kinetic energy graph and all we have discussed. Now, laws of photoelectric effect, these aren't different on you. If a separate question comes to write about the laws of photoelectric emission, PEE means photoelectric emission. If a separate question comes, these graphs were the conclusion of the experimental study that was done. If the laws come, 4 laws you have to remember. All right, if the question comes, you have to write the 4 laws. What is the first law? First law says that for a given photosensitive material or a frequency of incident radiation that is above the threshold frequency, photoelectric current is directly proportional to the intensity. That is the first graph which we have done. Remember the first graph which we saw, because number of photoelectrons were increasing. All right. So here you have to remember that the saturation current is directly proportional to the intensity. Saturation current is directly proportional to the intensity of the radiation. This is the first law. Laws are not different. It's just that whatever we have studied scatteredly, these laws on the basis of the experiment results only of the photoelectric effect given by Leonard and Millikan, that experiment which they did. On the basis of those only, some important points were taken and they were written as laws. So if laws come, you have to mention these separately. Write it properly in words. Draw the graph also. Everything is there in the notes that you can go through. Second, you have to tell that there is a minimum cutoff frequency below which no photoelectric effect exists. That is, you have to tell the definition of threshold frequency. What is the definition of threshold frequency? The minimum value of frequency of incident radiation below which photoelectric emission stops, or minimum value of frequency that is required to cause photoelectric effect. Second law is the definition. Third law. Third law were the two graphs which we had seen. That stopping potential, or you can say a maximum kinetic energy, basically maximum kinetic energy. It was directly proportional to the frequency of incident radiation. So maximum kinetic energy was directly proportional to frequency of incident radiation. Also, but this was independent, the same thing. This was independent of intensity, independent of its intensity. Last is something different. The fourth law is something different. Fourth law basically says that photoelectric effect is an instantaneous process. This is an instantaneous process. Instantaneous process means when this incident ray strikes the metallic surface, all right, and the entire photoelectric emission occurring and then the electron getting emitted. This process, the time lag is very, very small. The time lag is approximately even lesser or equal to than 10 to the power minus 9 seconds. This is such a small process. So see, if individually the graph comes, suppose here, if the experimental study is asked, then you will plot all these graphs which we have done after these graphs you will write. But if it separately comes to write about the laws of photoelectric effect, then you have to mention only these 4 laws. Then do not include other things. Then just include all these laws only. Understood? Tell me, any doubts still here? Clear? Just reply in the chat column. This portion, initial definitions, these graphs which will come, and till the laws of photoelectric effect. Reply in the chat column if you have understood or not. Okay, just note down this page, only this page, not the other one. Just write down this page. All right, class. Now, after this, we have the Einstein's theory of photoelectric effect. So let me discuss this also separately because this is also important and it can come in your exam. Einstein's theory of photoelectric effect. So one thing very basic first is that you have to remember that photoelectric effect is the result of interaction of the two particles. He said that this is because of interaction between two particles. Now, what are these two particles? Because in the question also, in your numericals also, you will be having the names of these two particles. One is a photon of the incident radiation. Why photon? Because it is coming from the sun rays, the photons which are present. So one is the photon. Photon is from the incident radiation. Photon is from the incident radiation. And second particle, definitely this is the electron, which is present in the photosensitive material, which is present in the photosensitive material. This was the first point that was given. Secondly, he defined work function properly. He gave the definition of work function property. That is, he told that the free electrons, they are bound within the metal surface due to the restraining forces on the surface. So minimum energy that is required to liberate the electron from the metal surface, this is called as the work function. So you have to mention about the definition of work function. Third point. Third point that he mentioned, that if this was mentioned that each photon interacts with one electron, then he says that when we are talking about the incident energy, incident energy means the energy which is being provided so that the photoelectric effect occurs. So this incident energy, this is made up of two things. This incident energy of the electron, suppose the electron is present. So this incident energy is made up of two things. Firstly, this is made up of the work function of the electron. Secondly, this is made up of the kinetic energy, which is used to move this. That's why you have the entire equation. Now see, firstly, let us talk about each part. Let's talk about incident energy. What have I concluded from Einstein's experiments? That energy of the incident photon is equal to the kinetic energy maximum which is present plus the work function. This is now helpful for your numericals. All the questions we'll be solving will be using this only. Entirely, we'll be using some numericals. We'll be solving the numericals. You have lots of numericals to solve. I think 10 minimum numericals are there from this lesson. So maximum kinetic energy plus the work function. Now, how can we write all these things? He gave the conclusion that energy is directly proportional to the frequency. All right, energy of the photoelectrons is directly proportional to the frequency. So here we have a constant that is h, which is known as the Planck's constant. This constant, this is known as the Planck's constant, whose value is 6.63 into 10 to the power minus 34 joules, which I was showing you over here. This one. 6.6. E is directly proportional to the frequency. So in order to remove the proportionality sign, we put a constant with an equal to. So E is equal to h nu. Nu is the frequency, E is the energy, h is the Planck's constant whose value is 6.63 into 10 to the power minus 34 joules. And since frequency into wavelength gives the speed of light, is the speed, and it gives the speed of light by, generally we have the equation as nu is equal nu into frequency is equal to c. But right now specifically when we are talking about it, we are talking about the electromagnetic waves. So electromagnetic waves definitely have the value of speed of light as their velocity. From here, frequency can be written as c by lambda. So you have one more formula as E is equal to hc by lambda. So yes, from here, what can we conclude? E is equal to h nu. Now, you can write E is equal to h nu. You can write E is equal to hc by lambda. So these are the values that are possible for the energy. If a question comes, you have the value of incident frequency, use this equation. If you have the knowledge about the wavelength, use this equation. Understood? Secondly, when we're talking about the maximum value of kinetic energy, half mv square is there. Velocity will also be maximum. This formula is definitely there. This formula will be helpful to calculate the maximum energy. Suppose if this is not mentioned, you have one more formula for it, which is multiply the charge into the stopping potential. For electrons, we write it as EV naught, charge multiplied to the stopping potential. So whichever quantity is given, if suppose you do not have the velocity in your equation, if you have the stopping potential, you can calculate the kinetic energy using this. If an individual question also comes, you can manage. If a total question comes also, that also you can calculate. Now work function is also the energy. But what is the difference between the work function and this energy? When we are talking about this energy is the energy of the incident photon. And when we're talking about the work function is the energy of the electron, the photoelectric effect through which we have the electrons coming. So this is the difference. So, but both are energies. If this is having the formula E is equal to h nu, this will also be having the formula work function is equal to h nu. But what will be the difference? The difference will be that energy of the incident photon can be anything, any value. But for photoelectron to be emitted, that energy should have the threshold frequency only. So this is the difference. Also, if threshold wavelength is given, you can use hc by lambda naught. So what are the differences between all these? They both are the values for incident. And they both are the values for the threshold. Now, any question which comes in the exam, you will be able to solve. How? Which type of question is possible? See, suppose I gave you a question just to calculate the energy, of the incident photon. Use these two equations. Suppose I gave you a question where I asked you to calculate kinetic energy. Use any of these which is suitable, which is giving you the correct answer. Suppose I'm asking you the work function, use this, or I'm asking you threshold frequency, use this, these formula are valid. Suppose I give you a total question, then use this, whichever is suitable. Now you can construct so many equations. Suppose I have the incident frequency, so I can write h nu. I have the kinetic energy, I have the work functions threshold frequency. So I can write it as h nu naught. From here, I can write the value of kinetic energy as h nu minus h nu naught. So one equation which I can use is h nu minus nu naught, like this. So these types of equations will be so many. But instead of remembering these many equations, it's better if you remember just this page. Remember this equation, that incident photon, remember this thing, that incident energy is made up of two things, work function of the electron and kinetic energy. If it is made up of these two things, what are the individual formulas of all these, so that you can deal with individual questions also and complete question of from Einstein's photoelectric effect also. Different equations can be constructed. Suppose I say this is hc by lambda is equal to, for kinetic energy I am writing half mv maximum square, for work function I am writing h nu naught. This is one more equation that can be derived. Instead of remembering these individual equations, it's better if you remember the entire spectrum. All right, this will be better to remember. Write down this. We'll see numericals from this part. Write down from here Einstein's theory of photoelectric effect. Okay, last topic for this lesson, which is left. Let me discuss that so that in the next class directly we'll start with the numericals. So formula portion, everything which we have discussed in today's class, please revise it and come. See, when we are talking about the graph, the question that can come to you is to determine the determination of Planck's constant and work function. Determination of Planck's constant and work function. So how the question can come is draw a graph showing the variation of stopping potential with the frequency of incident radiation in relation to the photoelectric effect. Like this, you can get a question to draw the graph also, or the graph will be given to you and you have to deduce the expression or derive the expression for the slope of the graph using the Einstein's equations, which we have studied. So let me first draw the graph. So graph will be plotted between the stopping potential on the y-axis and the incident radiation's frequency of incident radiation. So what type of graph we get? See, it's linear. I have already discussed how it's linear. Frequency is increasing, stopping potential increases. This was already concluded. Now, how to, the main important, this part is not very important. This you will be able to plot it by yourself. The important part is to get the values out of the graph. If I ask you, if I want to calculate the slope, of this graph, how will I calculate the slope of this graph? Or if this is intersecting, this is the y-axis, this is the x-axis, this is intersecting. So how much a value is this from the origin? At which value is it cutting? This intercept, what is the y-intercept? So basically you have to start with Einstein's equation only. That is, maximum kinetic energy will be equal to energy of the incident photon minus the work function. How can we write this? EV naught is equal to, I told you, you can write any of these equations. For energy, which equations? H nu. For work function, I'm writing work function as it is. If I divide the entire equation by E, this will be cancelled. What will I be left with? Stopping potential is equal to H by E multiplied to frequency minus phi naught by E. This equation is nothing, it's just resembling the main equation, that is y is equal to mx plus c. Why are we comparing this? Because this is a straight line equation. This is a straight line equation. What are all the terms? This is on the y-axis, we are getting it. M means the slope. So for the slope, we have h by e. That is the slope, which is the tan theta. This is equal to h by e. This is the variable on the x-axis, frequency, correct? This also only we have plotted already. And this is the y-intercept. Means which is intersecting the axis. That is minus phi naught by e. Why minus? Because in the equation we have plus. So it means that's why you can see directly this is coming on the negative x-axis, negative y-axis. Minus phi naught by e is the y-intercept. All right. So if a question comes to calculate the angle or anything from the slope part, how will you calculate? See, slope which is equal, slope is of a graph is always calculated using tan theta, then you will say tan theta is further equal to h by e, depending upon the question, if it is asked. All right, if it is asked, this is how you will be calculating. Otherwise, the question is very simple. Y-intercept can be asked to you. You know what's the y-intercept. All right. So if suppose work function directly is asked, so you can say work function will be E multiplied to the magnitude of intercept on the vertical axis, that is the y-axis. How? Because the equation was minus phi naught by E is equal to the y-intercept. So if I'm talking about the magnitude, I'll be taking its magnitude. From here, if I cross multiply this to it, I can get the value of work function. All right, you will be getting questions. You will be getting the graphs also. I have all these questions already written. Right now, first you quickly copy this down. This you have, this entire equation and derivation you already have. Just note down this part. This equation, this part, and the last part. That's it. Okay, class. Now we'll complete the numericals. This completes the theory revision. I'll be asking you the questions. First, we'll discuss this. The formula altogether I'll write from this lesson. Then we'll practice the numericals. So minimum 10 to 11 numericals. We'll be doing it in the next class now. Revise and come. Okay, class, you can leave now. Thank you so much. On Sunday, we'll meet now.
Ma'am,
Yes. Yes, Yusuf.
do we not have a de Broglie relation?
De Broglie wavelength.
Yes.
Yes, that also we'll be studying. That is there in your syllabus. This was the particle nature, no? So firstly, that's why I was discussing the particle nature. That is included in the wave nature.